Hello, everybody. This is Coach Meidenbauer here for AP Pre-Calculus. This is section 4.5. We're covering implicitly defined functions. And let's get rock and rolling here. You've seen explicit functions pretty much your entire mathematical career since you started doing anything with the variables. But that's when we have a function expressed y equals. Y equals. That's explicit. Implicit is when we have the x's and the y's and possibly the constants being kind of mixed in and out there. And you can see examples of an implicit equation, which is the same as the explicit equation, and there's the graph of that right there. Some implicit equations you're probably familiar with are circles, and we'll get to that right here on example 1 here. Given the following implicit equation, solve for y to create one or more functions that produce the same graph. So for 16 here, this is the same thing as a circle. If I were to move that 16 over, that would be a circle with a radius of 4. So what I want to do here is I want to move everything onto one side and then solve for y. So I'm going to add 16 to both sides and also subtract x squared from both sides. So I got y squared is equal to 16 minus x squared. Now to get the y squared by itself, I need to square root both sides. And when I square root a y squared, it's going to create two different answers here. So it's going to create a plus and minus square root of 16 minus x squared. And we're going to leave the answer just as that because the positive is a semicircle, which is a function. The negative is a semicircle on the bottom, which is also a function. So putting it together, give us our full circle there. All right, for letter B here, we're going to solve for y. And to do this, we're going to move all of our non-y's on one side. And then we'll collect our y's, take GCF and divide on over. So I'm going to keep negative 2xy plus y on the left-hand side, subtract the x squared, subtract the 6, and then take out a GCF of y on the left-hand side. So I'm going to end up with, sorry, we're getting some technical difficulties, which is very normal in these videos. There we go. And then this right-hand side stays the same. And then just divide over that negative 2x plus 1. Negative x squared minus 6 all over negative 2x plus 1. If you wanted to make that numerator positive, you totally can. Just divide everything, every term on the right-hand side by negative 1, and we can get x squared plus 6 all over 2x minus 1. You got to change all the signs, and we're good to go. Okay. For C here, we're going to have to use a formula that we're familiar with because we can't get all of the y's on one side like letter B because we're going to be stuck with an extra y. So we can't do that, but we are familiar with the formula factoring this as x plus y all squared. And this is why we have you memorize those formulas. So you can pick that out right off the bat. And then it's a little bit easier to isolate y. So we're going to add 1 to the other side. And then square root both sides. Again, going to give us a positive and a negative 1. Because you square root 1, you just get 1. And then solve for y here. We're going to get y equals negative x plus or minus 1. Which that means that this equation was actually two parallel lines. How neat. Next one, letter D. This is a fun one. If I didn't put that hint right there, I'm sure I could have you struggle for a little bit here. But we're going to use the quadratic formula for anything that looks kind of like this. So we're going to do y squared. Oop. Technical difficulties, again, to be expected. It's not ending. Oh, boy. Oh, boy. So we're going to get y squared plus xy plus x squared plus 1 equals 0. What's going to happen here is I'm going to have my a term be in front of there, b term in front of there, and then my c term is right here. So I have my a is 1 because I'm going to treat this as y squared. And what's in front of the y from a b term? That's an x. What's my c term, which is my non-y terms? X squared plus 1. Okay. Oh, I just noticed something here. I have a typo in my notes. We're going to rewrite this as a negative 1 right here. So let me change this. Oh no, how do I change colors? Oh, eyedropper. There we go. We're going to change this to a -1. Okay. Make a little note right here. Okay, so to make that change, I apologize for this. There we go. Okay, otherwise this problem kind of gets weird. This makes this problem exist so we can graph it. I like how I spelled change with the note E. There we go. So anyway, I like how I wrote please. I am so polite. My mommy raised me right. Okay, so we're going to do y equals. Oh boy, what happened? Well, oh boy. Okay, we're going to get y equals -b plus or minus square root. Oh boy. Oh. One of these days. -b plus or minus square root of b squared, which is going to be x squared, minus 4 times a is 1, and then c, which is going to be x squared minus 1, all over 2a, which is just 2. Clean that up a bit here. Why did you do that? Y equals. Why are you doing this to me? Deep breath, says my mommy. All right, here we go. Oh my gosh. Where am I? Deep breath. If I just zoom in more. So this will be y equals -x. If I were to simplify that inside the radical, I'm going to get 4 minus 3x squared. I hope that's what I get. Oh, I have the answer key next to me. I can probably look at that. 4 minus 3x squared all over 2. All right. And there you go. That's what y is equal to. Why am I boxing this one and not the other ones? I don't know, because this is zoomed in. Okay, so there you go. There's those. Now, the last time I did this video, my video just froze and deleted right here. So, all right. Given the implicit equation, solve for y by completing the square. And again, for all of these, you can do this too. You can check your answers using Desmos. You can type in the original equation and then the multiple equations that we have. The one that doesn't have multiple equations is b. So b is solvable as this implicit solvable as an explicit. But we're going to go ahead and go through completing the square here. There's a lot more completing the square in Unit 4. I'm going to keep it really basic for this, and we can use Desmos to check. So here we go. When we complete the square, what I want to do is I want to have all of the y terms collected together and then all the constants on the other side. I don't care about the x's. That does not bother me whatsoever. That way I can have variables on one side, constants on the other. So I'm going to leave the x squared here. It doesn't bother me, but I'm going to wrap this y squared up minus 8y. And I'm going to put a plus a blank here. Equals, because I'm going to add 3 to both sides. Equals 3 plus blank. When we complete the square, what we're trying to do is we're trying to rewrite this as a y minus or plus something all squared. We're going to take the b term with the y's, cut it in half, and square it. So what's half of -8? -4, square it, you're going to get 16. What you do to one side, you have to do to the other. So this is going to be a plus 16 over here. X squared, rewrite that, plus, this is why we did it. This becomes y minus 4 squared equals 19. Okay, so the whole point is to get to that y minus 4 all squared. Once we do that, it's pretty simple to slide that x squared over. So we're going to get 19 minus x squared. Square root both sides, and when we do that, we're going to get y minus 4 equals plus and minus square root of 19 minus x squared. And when we slide that 4 over, we're going to get 4 plus or minus square root of 19 minus x squared. And there you go. All done. All right, next one, same idea, but a little more complicated, because when you complete the square, the term in front of the, or the constant in front of the y squared needs to be a 1. So watch what I do here. First off, I'm going to subtract 1 from both sides. So you'll see that in a second. Minus 4. What's going to happen here is I'm going to divide out a negative 4. So I'm left with y squared minus 4y plus blank. So all I did right there is I just rewrote this. I took out a GCF of a negative 4 out of all my y terms on the left-hand side, leaving with that right there. If you're confused by this, you can distribute that negative 4 back into the y squared and then the minus 4y, and it will be the same thing as the top. And then to balance this out, I have minus 4 times blank, because whatever blank I put on the left-hand side, I need to do times negative 4 of that on the right-hand side to balance it out. So half of negative 4 is negative 2. Negative 2 squared is 4. So that is 4, and then that is 4. So I'm left with x squared minus 4 times y minus 2 squared equals, this is going to become negative 17 on the right-hand side. So let's go ahead and subtract x squared on both sides. So negative x squared minus 17. Divide everything by negative 4. That's going to give me a y minus 2 squared equals, and divide everything by negative 4. Why don't I just make everything positive on the right-hand side, just because it makes it a little bit nicer. All those negatives will cancel out. And then I'm going to take the square root. I'm going to finish it up here in this little corner. Take the square root of both sides. So y minus 2 is going to equal plus and minus. Square root at the top is just x squared plus 17. If I do the square root of the bottom, it should be a 17. Square root of the bottom is going to be 2. And then so y equals 2 plus or minus root x squared plus 17 all over 2. All right, last part here. Given the implicit equations in x value, solve for y. So I'm going to plug in substitute in a 1 into x right there, and right there. So these all become 1s. So I'm going to get 1 squared plus 4y squared minus 8 plus 1 equals 1 cubed minus 3. So if I clean that up, I'm going to end up with a 1 plus 1, which is, you know what, whatever. I'll just go slow. Oh, there should be a y right here. That's an oopsie. Minus 8y plus 1 equals negative 2 over here. So if I combine everything together, I'm going to get 4y squared minus 8y plus 4. Is that correct? Very good. If you said yes, that is correct. Let's divide everything by 4 here. Look at my notes to see what I did. A couple different routes to take. We'll divide everything by 4. And this does factor into y minus 1, so it's y minus 1 squared. So the answer is y minus 1 is equal to 0, so y is equal to 1. So there we go. If you wanted to, you could always sketch that into Desmos, check your answers. I don't have time for that. I'm not going to do that. It's a you thing, not a me thing. Last thing, we're going to substitute in this negative 4 in for this x right here. Should be a little bit of review to get you ready for your AP exam. Add 4 to both sides. We're going to get e to the y equals 3. From here, I can solve for y just by doing the circle method. Or what the heck did I call it a long time ago? The looping method. There we go. So this is going to be base e, so it's going to be ln of, oh boy, we can't finish strong, can we? This becomes ln of 3 is equal to y, and that's it, just by looping it. Why am I boxing that one and none of the other ones? Nobody knows. All right, that's it for this video. Again, I am Coach Meidenbauer. This is AP Pre-Calculus. Do not forget to like and subscribe.